Good morning, good afternoon, good evening. Welcome back to Chapter 36. We're talking about population ecology. In the last video, we talked about how individuals are dispersed throughout their environment. The dispersion patterns, random, clumped, and nearly uniform. Let's move on and talk about how populations change in size. They can gain individuals through birth and immigration. They can lose individuals through death and emigration. We hear the term immigration a lot. Immigration obviously means someone is coming here, but if they're coming here, it means they left somewhere else. So if they are immigrating to America, they have emigrated from somewhere else. Mexico, China, wherever, who knows. Humans are not the only ones that emigrate. But animals, obviously, they do it too. They will leave an area and go somewhere else, move on to greener pastures. Population growth, the way populations will grow is a population can only be so big. A population can only be as big as the environment can support. And so each population will have a maximum size, and this maximum size is however much the environment can support, and the size of that population will only be so big usually. Let's do a thought experiment. We have a cage. We have a hamster cage, and in this cage is enough food and water for 20 hamsters. We put 2 hamsters, a male and a female, into that cage. And we're going to assume that each reproductive cycle, we're going to double the number of hamsters that are in that cage. So after the first reproductive cycle, our 2 hamsters have now become 4 hamsters. And how much food and water is in the cage? There's enough food and water in the cage for 20 hamsters. So are the hamsters happy? Are they content? And the answer is yeah, they're fine. There's plenty of food and water. There's more than enough food and water for our population. All right, so we have another breeding cycle. We go from 4 hamsters to 8 hamsters. And what's the situation like in the cage? It's fine. There's enough food and water for 20, and we have 8. Okay, great. Next breeding cycle, we go from 8 hamsters to 16 hamsters. What's the population, what's the situation like in the cage? It's still fine, because remember how much food and water is in the cage. There's enough food and water for 20 hamsters, and we have 16. So does that mean that there's food and water left over at the end of the day? And the answer is yes, there is food and water left over at the end of the day. And if that's the case, then there's plenty. Every individual can have as much as they want. So then we go from 16 hamsters to the next reproductive cycle, and we go from 16 to how many? To 32. Now, is everything okay? And the answer is no, everything is not okay. Why not? Well, because we have 32 individuals and we only have enough food for 20. So when we say that a population can only be as big as the environment can support, usually, that's what we're saying. So now what has happened is this population has shot past what we call the carrying capacity. The cage that we have has a carrying capacity of 20 hamsters. What has happened to our number of hamsters? And that is that because they had plenty, because they had ample food and water, they've now shot past the limit of the cage. So now what's going to happen? Well, if there's enough food and water for 20 and we got 32, that means 12 of them are going to die. Well, I mean, no, that's not what's going to happen. 12 of them are not going to die. Are the other 12 that don't, if there's only enough food and water for 20, are 12 of them just going to sit back and say, no, it's okay, you get what you want, I'll just sit over here and starve, it's fine, I don't mind? No, that is not what's going to happen. What's going to happen is that they're going to fight because there's not enough food. They're all going to get weak. Some will get enough food, but not most. And it won't be just 12 that die. It's probably going to be more like 15 or 20 of them that are going to die, because when they're hungry and tired, they're more susceptible to disease. Any kind of underlying health problem that they might have, they're going to be more likely to die from it because they don't have enough food, they don't have enough energy. So what happens is you're going to have a crash after that shooting past of the carrying capacity. A population can only be as big as the environment can support. And once the population goes past that number, you're going to have problems. There are two growth models. One is the logistic growth model. The logistic growth model is the idealized population growth, which is slowed by those limiting factors. The population increases quite a lot in the beginning and then tapers off and levels off once it reaches that carrying capacity. We already talked about this concept of carrying capacity. Carrying capacity. Populations grow the fastest when they're about half of the carrying capacity. And if you think about our hamsters, 2 to 4, that's only an increase of 2. 4 to 8, that's only an increase of 4. 8 to 16. 8 is about half of 20. We easily doubled our population from 8 to 16. That was an increase of 8 individuals. It grew really fast when it was about half of carrying capacity. If you can keep a population about half of carrying capacity of the environment, you can have very, very fast growth. How do you keep them at half carrying capacity? You got to kill them. That's how you have to do it. And so when we talk about managing herds, like managing herds of cattle, managing herds of deer, wild herds, that's what we're talking about, management, keeping that about half of the carrying capacity. And then you don't have individuals that starve over the wintertime. This is fur seals. Breeding of fur seals beginning from 1915 after they realized they had killed almost all of them off for making fur coats. We start off with about 2,000 individuals. They enact protections of the fur seals so that they're not going to be killed by hunters for fur coats. And then over the next 40 years, the population of the fur seals fairly steadily increases. This is that logistical growth until we reach roughly about 1950, 1960. And what has happened now to my growth curve? What's happened is it has leveled off because the individuals have hit that carrying capacity. And apparently for this population of fur seals, about 10,000 individuals is carrying capacity. So logistical growth, slow in the beginning, rapid about halfway through, and then it tapers off. The growth slows as we get close to that ceiling, as we get close to that carrying capacity.